All right, let's begin, everyone. So my name is Alec. I'm your TA. For those of you who were here last week, for those of you who are here for the first time, I'm your TA. Kyung is also the other TA, and we have one undergrad TA who's holding office hours. We're your TAs. We're here to help. We're here to help with your homework, your R code, and basically anything you can ask about this course. So today is the second R session. We'll be going over some of the things you'll probably need for the homework if you haven't already done it. If you have, then great. And if you have any questions, feel free to stop me while I'm showing you the commands. And if you have any questions that are not related to this, we can take them after we go through the script and you see everything that you'll probably need for the homework. So now, I think it would be pretty useful if you follow what I'm writing so that you can have it on your own in your own script. So can everyone open RStudio and create a new script? So just launch RStudio, and I think this is the button, and create a new R script and save it, whatever. Yeah. So you can use this command for now. You don't need to get rid of everything right now, but if you want to get rid of it, this is fine. So you can use. Is this large enough? Can everyone read this font here? RM. No, that's fine. I guess it's fine. So RM. So if you have a, let's say, all right, let's give it a name. So if you have some number, let's call it 5, and it's called ABC. You can remove this from your environment by writing RM, short for remove, ABC, and here you'll see it'll disappear. And if you want to remove everything, then just do this. So just remember this command, and this will remove everything. I'll show you. So if I do this, it removes everything. All right. So did everyone create a new script, an empty script, just script whatever, call it .r? Okay. I guess we're fine. Okay. So R has a lot of built-in data sets. Sometimes if you just want to test some stuff out, you don't have to open your Excel and import from the homework. So you can just do, for example, this is a data set that's very famous called iris, and you can just write data and in parentheses write iris, and this will give you this data set iris. So now when I do head iris, it'll show me. So this is the data set. If you want to see how big the data set is, you can look at the dimensions of the data set. This is just DIM for dimensions. So it's 150 rows and 5 columns. You can also use nrow or ncol, I think. Ncol iris should be fine. As you can notice, I'm using the shortcuts, which is, yeah.
Whenever I enter it, it doesn't come up. Never data iris from
Yes, but then you should run the next command, which is head iris. Did you try running this? So,
okay.
Yeah, okay. So this is this is how. So this is how you would plot. You don't have to copy this. It's a big line. This is not for the homework. I can show you. This is kind of what the data set looks. It has some petal length, some petal width, and it has 3 types of flowers. And you can see that this flower is, I guess, smaller. Has smaller petals. They're both shorter and narrower, and the other 2 are somewhere here. So this is one of those many data sets you can test. For example, if I want to, let's say again, I have these columns. Let's say I want to find the mean of the, I want to find the mean sepal width. Sepal is, I'm not even sure what it is. I know it's not a petal, it's something else from the flower has. So you can do iris, and if you do the $, it will automatically pop up, give you all the columns that are here. So for example, we have sepal.width, and I can take the mean of that, and I guess the mean is 3.05. Now, for the homework, the stuff you're gonna need is pretty basic. So when you want to create a vector, you can do it like this. So this would be 1, 2, 3, 4. You can also do it manually if you want. This is the same. As you can see, it's probably better to use a shorthand to just say 1, 2, 4. Now, if you want to get even more specific than that, you can also use the seq function that gives it a sequence. So for example, I can say that I want a sequence from 5 to 11, that goes by 2 every time. So if I would do that, I have 5, 7, 9, 11. Yeah. Yeah. Thanks. Yeah. So now a few of you were asking last week about normalizing, and it's enough to add that that argument in the function called freq equal to t, so that you can get the frequency. But if you want to do it manually, this is one way to do it. So for example, if you have, let's say that v is again 1, 2, 3, 4. Now, if I divide v by its sum, I should, because the sum, if I divide it by the sum, then automatically it sums to 1. I guess this is kind of obvious, but this is the way we would plot this. For example, if I have a bar plot of v, this is how it would look like. So if you remember, it's 1, 2, let me zoom in. So it's 1, 2, 3, 4, right? But I can also divide it by the sum so that I can get the frequencies. And as you can see, the only thing that changed is now it gives the actual frequency. So the probability of this is 0.1, 0.2, 3, and 4, and they all sum to 1.
What is the v function?
The what?
V?
The v? No.
Is that a data set?
No. V is just a vector. So v shows for, I just called my vector v, and I call it, so v is just 1, 2, 4. That's what I call it. That's all. So you can see here, v is an integer that has 4. It's 4 integers. That's all there is. Now, for the homework, you need some bar plots and mosaic plots and a couple other stuff. Now, for this R session, we'll be going over using the Titanic dataset, which is, I think, kind of interesting. You can download it here. So just launch this line. So install.packages, and then in the parentheses and in quotes, put Titanic. So it should work for everyone. I have it already loaded, so it's asking me, but for you, I think it's going to run immediately, and you don't have to do anything. If it's successful, you should be able to run the next line, which is library Titanic. Now notice that here I don't put quotes. So here you need to put quotes, but here you don't. That's how they wrote it. It's not, yeah. Yeah, so if this is some data, like some column or whatever, if you divide it by its sum, you'll get the probabilities. That's useful, I think. No, there is a no. When you plot a histogram, you can give it the frequency. You can add an argument that says freq equal to t. It'll do it for you. But if you don't want to do it, if you're going to do it manually, because some people were asking, you can just do it like this and then give that to the histogram. It's either way is the same. This is just useful in case sometimes it does. We'll use it later more. You'll see it pops up. Now, I'm just waiting for everyone to basically install and load the package. So this installs the package. This only needs to be run once. If this is successful, just delete the line. You don't need it anymore. Then when you, for example, if you have a script, you just at the top of the script at the beginning, you just put library Titanic and it'll load. When you're using the data, of course. Now, in Titanic, it loads a bunch of stuff for you. So it's not here. You can't see it because it's inside a package. But I know only because I look at it. But basically, it gives you a training and test data set for this is for machine learning. But that doesn't matter right now. You can look. So this is a data frame, I think. You can check. So you can always check what your data is by using the function class. So for example, v should be a numeric vector. And if I say class v, it'll tell me it's an integer because it's numbers. They're not real. So they're not floating point numbers. They're not 1 point something. They're just numbers like 1, 2, 3. So it's an integer. And for Titanic train, it'll tell me that it's a data frame. I hope. Yes, it's a data frame. You can visualize. Yeah. Yeah, it's fine. Either way is fine. I think I changed some. I think here when you do this, it'll change to numeric. If I'm not. So for example, if I, or maybe it was here. Not really sure. It's. Oh, right. So if you do it manually, I guess there's a very. I guess it's an unimportant difference. But if you do it manually, it'll say numeric. And if you do it like here, it says integer. It doesn't matter. Either way is fine. So. Anyway, I hope that everyone can run this line. Now, if everyone can run this line, then we're good. So this will show you the data set. So we can see here. Oh, I guess I can move this here. Huh. Weird. Okay. Anyway, the data set is, I think it's quite big actually. Let's see how big it is. I think it should have like 2,000. Okay, so it has 891 passengers and 12 columns. So each column explains something about the passengers. You can see here we have name, sex, age, ticket, fare, etc. We'll be using this data set for, yep.
Sorry, once you install the package,
Mhm.
I did the library Titanic and it showed up with the class.
You
The underscore train. You have to do that.
no. So just run this line. This will load the package, and then once you have it loaded, we'll be using this onwards. So just follow the lines here. So basically, this is just to show you that it's a data frame. This is to see how big the data set is. So this is the important thing, and this is just so you can see what's inside the data. So you have the name and the cabin ticket, etc. So what we're gonna do here is we're gonna take all the columns that we need. So in your homework, usually you'll need all the columns, but in case you want to drop something and you just want some of the columns, you can always choose them. So for example, here we can write this. So I'll call my data frame df, and I'll take from Titanic train only what I need. So here, this is an important thing where you have a comma, and you have two things. So because the dataset has rows and columns, the thing what's before the comma is what you want to select from the rows, and what's after the comma is what you want to select from the columns. So in our case, the rows are just 1 through 891, and we just want all the rows anyway, so we'll just get all the rows. To get all the rows, you don't write anything, you just leave it blank, which means just to get all the rows. Now for the columns, for our case, we'll just be using a few. So we'll just put in a vector the names that we actually want. You can see them here on top. So name, sex, age, parchment, ticket, fare, cabin. So I'll just input them manually. Yep. So C is a concatenation function that takes a bunch of, let's say, numbers or words and puts them together in one long vector. That's all it does. So for example, here we need to put them all together in one, because this is always expecting one thing here. So if it's one column, it's fine to put it like this. But if you have two, then you need to put parentheses around them and add C, because otherwise the code is just the program is just going to get confused basically. So you need to put them like this. So this means I'll be selecting just survived and P class. I think this is the like first class or economy or business, something like that in 100 years ago. So for example, if I do this, I'm just selecting two columns. I'll just be selecting survived, which is here, survived, and P class. And if I look at my data now, you'll see that I only have, so from now on, we'll be using df. As you can see, I only have survived and P class. I threw away everything else. But in our case, we'll be adding these two as well. So we'll add sex and age as well. So if I rerun the line again, so don't forget, now the important thing is once you change something here, you always need to rerun the line, otherwise nothing has changed. So if I write something here, nothing has changed. But if I run, we'll get an error because it doesn't understand what this means here, what this here means. And RStudio is very useful in that if you do this, it'll know something is wrong, because now I have a closed parenthesis that I haven't opened anywhere. So it tells me that there's an unexpected token. Cool. All right, don't click there. Oops. Sorry. Now if I select these four columns, you can see it's exactly what we want. Yep. Okay. Yeah. All right. So this is what our data is going to look like. Another way to visualize what the data looks like. Yeah.
What's the keyboard shortcut on Mac to run it? To have, like,
Oh, it's Command Enter on Mac and Control Enter on Windows. Yeah, I'm using them all the time right now. Yeah. Yeah.
why do you have to put the comma after the bracket, close bracket? Let's see this.
So as I said, the comma here is that before the comma, you're selecting the rows, and after the comma, you're selecting the columns. So here would be, so for example, let's say I just want the first 3 rows. I'll give that here. I'll say, just give me the first 3 rows, rows 1 to 3, or for example, rows 2 to 4. Or again, I can put them in C and say, give me the second, third, and fourth row, or the second, fourth, and fifth row. And then for the columns, give me survive, P class, sex, and age. You can also give it numbers here. if you want to, but that seems unnecessary because you'll have to count which column it is here. But I don't think anyone wants to do that. Like, I'm not gonna count that age is the 5th or 6th column here. So I'll just give it, if it has a name, you can just use the name. So that's what it's doing here. So for example, if I do this, as you can see, the whole data set just has 3 rows, 2, 4, and 5, and the 4 columns that I selected. So what you're doing is just taking whatever you need. But in our case, we want to take everything. So, but if you do this, so I actually think this is gonna work, but it's still better to, it's more, so that you don't make a mistake, it's better to just leave it like this. Again, the space doesn't matter here. So for the homework, you're gonna need to use tables a lot. Like almost every question, I think, uses tables. What tables does is you can take, for example, 2 columns like survived and sex. So I'll show you what that would be, what that would look like. So for example, here we have the 4 columns, right? So you can take survived and sex, and you can do what table means to look at all the possible combinations. So for survived, we just have 0 and 1 as combinations. For sex, we have male and female here, so that when I take the table, it'll just give me a 2 by 2 matrix. So it's a very simple but useful function. So that here I can see that there are 468 males who I think did not survive, and 109 that did, and 230 females that did, and 81 that did not. So sometimes, which is more useful, usually in your data set you won't have 0, 1 numbers. You'll have more usefully written stuff like survived or perished. For example, here I'm gonna do that manually, and you can just copy this line here. It's not, you're not gonna be using this a lot because the data sets in the homework already have them written well instead of 0s and 1s. But here what I'm gonna do is I'm gonna take survived, and survived is a 0, 1 column. And if it's 1, it's gonna write survived. If it's a 0, it's gonna write perished. And this is what you just need to write basically. So just copy this line here. And after, so we'll look here how it's gonna look like before and after. So before, the table looks like this. We have 0, 1 male, female. It doesn't really, like, we don't know much. If we don't know what's going on here, we don't know what 0, 1 means. But after I do this, I'm gonna change the names here. So we're changing the names. And after so this is only done once. After, if I do the table, as you can see, now it says perished and survived. And also, if you look at the original data set is changed as well. So survived is not 0, 1 anymore. Now it's perished or survived, basically. Whatever we put here, you can write whatever you want.
How do you know that if they're right one, they survive the perished?
Sorry?
How do you know that the survive, like what's the 0 or what's the 1?
No, so it looks like, this is what I'm telling it. I'm telling it here, so look at this column of 1s and 0s, this is survived. And I'm telling him put survived if there's a 1 and put perished if there is a 0. This is what the command if else does. It takes 3 things. So you're not gonna need this. This is more programming than you need. So basically here you have a test, yes and no. So in case the test gives yes is 1, true is 1, and no is 0. So basically if it's a 1, it counts it as a yes and it puts survived. If it's no, it just puts perished. That's all it does. It's not, you're not going to be using this much, so don't worry, you can just copy this line right now. The important thing is that now your data set looks like this, basically. Now, we're gonna, so if you write this, so if you just write this here, it'll give you the output of this line here. It'll give you the output in the console, but it's not doing anything other than that. What you usually want is to put the output somewhere. So I'm gonna tell it to put the output in my variable called tab. I just shorthand for table. So here, I put it in the variable tab. If I want to see what's inside tab, I can just write tab and run this line. It'll tell me. It's basically what you're expecting the table here. So what's useful about the names that we gave them here is that you can not only use numbers to select parts of the table, you can also use the names. So for example, if I want to the second row and the second column of this 2 by 2 matrix, it'll give me by indexing it by numbers. But if I want, I can also use the names. So if I do tab survived and male, it'll do the same thing because as you can see, this is the second row and column and it's also survived and male. So you can see for the row I'm selecting survived and for the column I'm selecting male. So this is kind of useful in case you forget which row you're looking for. Now, another thing that will be very useful for the homework is a bar plot. So bar plot is well this basically. It plots bars, and the bars are going to be as high as so. Here we're choosing. If you remember what this does, we're choosing the survived row and all the columns, which means that here in our table we're taking the survived row and all the columns, which means you're taking these two numbers, right? So for female it's 233 and for male it's 109, and I can plot this here using a bar plot. So if I run this, that's what it does for me. As you can see, the height of the bar plot, and zoom in, is, well, you can see that it's around 230, and for the other is around 100, 109 or 107, whichever it was. So this is one useful function for visualizing, which you'll be using. There's another, a pie chart. This is not commonly used because it's not very useful, but you can also use a pie chart, which is basically the same thing. It just gives you the proportion. So you can see that the females are a larger proportion of the people who survived, and the males perished more. Now, another very useful function which you'll encounter in the homework, and this is really important. If sometimes you're stuck, just look at the instructor tip. It usually has a lot of good info. So if you go to the homework, and I have it open right now, but on the right-hand corner, so the top right corner, there's I forgot what the name of the button is, but you can click and it says View Instructor Tip. It usually gives you a whole function that you just need to run in R. And the only thing you'll need to change is, for example, what your data is called. So for example, let's say that in the hint it'll say run prop table on your name of table here. And then that's all you'll need to change. You can just use prop table, and then you can change this to whatever you call your table. In our case, we call it tab. So now we'll see what the prop table function does. Yep. Oh, yep, we'll get you. So again, this is our table. Now what prop table does is it normalizes probabilities, which is very useful for this homework. Yep. Here with the arrow. So this was the table that I used, right? And if I just run this, it'll run, but it'll give it here in the console. But this is useless because it just gave me the data which I can look at, but I can't use for anything. If I actually want to use the data later, I need to store it somewhere, and I'm storing it in something called tab. That's all. You can name it whatever you want in your case, as long as you keep using the same name. Yep.
Did you survive the mail after tab to like identify the two?
No. So before I save the table is when I changed survived and paired. If you're talking about this line here. So,
I'm talking about the one after tab. Like
this one?
Yeah.
No, this is just selecting part of tab. This is if I want to look at what's inside. So this is the whole table. And if I just want to look at the second row and the second column, I'm going to tell it give me the second row and the second column. That's all I'm giving it here. This doesn't change anything in the table. It just gives me some numbers if I want to look at the number specifically.
But the line below it is not supposed to.
No, this is the same thing. This is the same thing as this. It does completely the same thing. So survived and male just selects the row that says survived and the column that says male, and which is just one number. That's all it does. So here, we're gonna take these two numbers. Oh, I actually went over this. I forgot. Anyway, the prop table part. So this is very important for the homework. So you'll be using prop table a lot. Why? Let's say I have these numbers. It's gonna ask you what is the probability of the person being female and survive, right? And to do that, you'll need to take 233 and divide it by the sum of all these numbers, right? Because that will give you the probability. 200 females survived out of all these people here. But there's an easier way to do that, which is just using prop table, which is doing it automatically for you. So if I do prop table, it's going to give me 4 numbers here. And if you want to add these numbers up, you're going to see this, they sum to 1, which means they give you actual good probabilities. And that's great. Right, so it's 0.52, 2.6, this is 78, and 12, this is around 90, plus 9%, so it's like 99%, which means it's an actual probability. Now, this is going to be useful sometime, but what actually is going to be even more useful are conditional probabilities. So what you want to do is look at conditional probabilities like this. So prop table tab, and then if you add a comma after the tab and type 1, it'll sum over the rows. So it'll take the sums of each row and then it'll divide. So here, what's going to happen is it's going to take the sum of 81 and 468. It's going to sum those two up, and then it's going to divide both of these numbers by the sum. So why this is useful? This is going to be useful because now these two probabilities sum to 1. Now when someone asks you, let's say that the person perished, what is the probability that the person is a male given that the person perished? And that's 0.85. That's the probability. And and the probability it's a female, if it perished, is 0.14. That's why this is very useful. And in the other case as well. So if the question is what is the probability that the person is female if he or she survived, then this is the probability you're looking for. But to do that, you need to sum. You can do this manual as well, but there's no need to do that manual because it's just a lot of effort. Yeah.
So how is that percentage different from the one without the one?
Yeah. Let's. Yeah. Here. So this is the first one, tab, and this is the second one. So the first one you're summing over everything, and then you're dividing. So here you get probabilities like what is the probability that the person is male and perished, but it's not the same as the probability of him or her being male if they perished. This is a different probability. So here I'm telling you if the person perished, what is the probability they're male or female? But here I'm not asking you for that. Here I'm saying what is the probability of a person is male and perished at the same time. That's why these are different numbers. Here all of them together they sum to 1, and here each row sums to 1. So this is called a conditional probability because you're conditioning on some fact earlier. So because here the question is going to be something like we know that the person survived, or it's going to say something like given that the person survived, what is the probability that it's female. This is more common in the homework than the first one. I think the first one is only used once or twice. It's not used a lot. This is more common. And it's not going to be given in numbers like so. It's just going to be a textual question. It's going to be a sentence that you'll have to understand. So be very careful when you're reading the sentences. There's a difference between given what is the probability that the person is female given that he or she survived, and the probability that the person is female and they survived. That's what you need to be careful for in the homework. Yeah. Yeah. Oh, okay. Yeah. Yeah. If you have any questions not regarding this, ask Kyun for the general questions about the script. Yeah.
So by conditional, you mean that just one thing is given?
Yeah, it's gonna be most of the time you'll be asked about one thing given something other than that. So for example, you'll have something like what is the probability that a person is smoking given that they are aged between 45 and 64. I think there's a similar question to that. So this is the same here. Now the other thing that's useful is to sum by columns, obviously. So for example, now if I write 2 instead of 1 here in this line, so this one, as you can see, sums over rows and then divides by the sum in each row. This one sums over columns. This one is also very useful because sometimes now you may get the probability that's actually kind of the opposite. Now, for example, this sums to 1. So let's say given that the person is female, what is the probability that she survives? And this is the probability. And given that the person is male, what is the probability that he survived? And this is the probability. So you can see here this is actually a very useful graph. We're gonna plot it here. So this is for example how I would do this manually. So let's say that I have this table, this function that sums across rows, right? Let's say that I want to get this number here, 0.31. Well, I can do that by first selecting the number in the corresponding table, which is 109. So I can get that how? I can get the second row and the second column here, right? This is 109, as you can see. And I can divide by the sum of the whole row. So the sum of the whole row is going to be 233 plus 109, which is 342. So this should be 342. If I take the second row and I sum over the whole row. Let's see if this is actually, yep, 342. So this is a manual way to get the number here. So if I do that manual, I'm gonna get 0.31 this is the way to get it manually. But you don't need to do that. There's no need because the prop table function is actually really useful, and you have to worry about making. So here, as you can see, it's easy to make a mistake. If I did the opposite here, it's not going to be what I'm looking for. This is gonna be the other one, right? If you remember, if I sum across columns, I get this number here. As you can see, if I make a mistake here and I put the 2 for the column instead of the row, I'm gonna get that number, which is not what I wanted. So be careful. And if you don't want to be careful, just use the prop table function, obviously. Okay, so as we said here, this one was very useful. Summing across columns, you can see that there's a very different survival probability if you're male or female on Titanic. As you can see, the actual like the movie that when they said women and children first, I guess it was actually this very factually accurate, because as you can see, a lot more women and I guess children survive than men. And we can sometimes it's hard to see that using these probabilities, but it's much easier if you plot it using a bar plot. So to do that, we can just use the bar plot function and give it the prop table of our table, and to sum across columns we give it a 2, and we'll add the legend later. So this is how to plot a bar plot. You can see we have the bar plot. Now the reason we would add a legend is to know which darker region corresponds to what. So we'll just add another argument here. As you can see, I'm going to add a comma and write legend equal to t. And now I had the legend. So here, because the screen is very zoomed in, it's really horrible, and you can see it covers the whole graph. But if I click zoom, oh no, wow, this is... All right, well, on your screens, it should look a lot better than here. And this is really weird because it has to be really zoomed in. But basically, let me try that again. Nope, doesn't work. Anyway, on your screen, it should look much nicer with the legend. Yeah. Oh, so legend is either true or false. By default, it's false, which means don't put a legend. If I want to put a legend, I need to tell it to put a legend, which is adding t, or true. Both work in either case. So if I say false, it's not going to put a legend. And if I ignore it, actually by default it assumes that I don't want a legend. So if I do it like this, it's not going to do anything. Yeah.
I just have a question on the.
Specific, yeah. I guess you have it. Okay. So. Yeah. Another function that's really useful is a mosaic plot. I think you have it in a couple of questions for the homework. So this is another function that's kind of useful. It'll ask you for a mosaic plot. As you can see here, this shows you the probabilities that we just calculated using prop table. Notice here that I'm not using the one that sums by columns. I'm just using the regular one where when you sum all of these, it sums to 1. So here, I'm using that for the mosaic plot. And if you can actually visualize it, basically the area of this whole rectangle here is 1. And then the area of each of the smaller rectangles is going to be however big this is, right? So here this is 52, which means this is going to be a huge... So male and perished is going to be basically half the area of the whole rectangle. As you can see, male is here and perished is here, so you can see this is basically half the area of the whole. Why this mosaic plot is useful is because you can look at if there's a dependence between the two variables. So as you can see, age and sex actually are very dependent on each other. So you can see that if they were independent of each other, this line would be here or this line would be here. Anyway, these lines would both be at the same place. Since they're not, there's obviously a very large difference, which we noticed already, but by noting that basically all of the men died in Titanic in the disaster. Now sometimes you'll need to. Now let's get back to the data frame that we had before. I use head df just to visualize it. This doesn't do anything except visualize it for you. So this is what we have here, right? In case we forgot, which is I forget most of the time, so I need to write head df again just to like remind myself which columns I have here. So here I can take these columns. So I can take one of these columns, and let's say that I want to know which rows are survivors. So the way I can do that is I can write this thing here. If I do this thing here, it's going to give me for each row it's going to give me a 0 or 1, or I think a true or false. So if the row says survived, it's going to say true. If the row says perished, it's going to say false. This is really useful because that's how you can calculate proportion. So for example, if I want to ask what is the percentage of people who survived, regardless male or female, just the percentage of people who survived on Titanic, I can get it like this. I just need a couple of more things here. So the first thing to do is do this. So basically equate survived to this column and see where it's true and where it's false. Now, if I run this code, it's going to give me basically 900 true or false, which is sometimes too much and it's going to truncate. So I'm going to run the command just to see what we get, but I don't want the whole thing, right? So what I'm going to do is going to use head here. So I just want the first 6. So I'm gonna write head and then do this so that I get the first 6. Why I want to do that is because I don't want to clutter our student, because I can basically compare more easily. So for example, if I run this line, right, we see perished, survived, perished, perished. If I run the next line, as you can see, it's false, true, 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 false, false, which corresponds to the rows that survived. Now the next thing is, now if I want to cast this as numeric, so if I want to use numbers instead of false or true, I can write it as numeric. We actually don't need to write this. I'm just gonna show you that it's actually when you see true or false in the background, it's actually just 0 or 1. So if I write as a numeric, and again I'm gonna use head because I just don't want to see the first. I want to see the first 6 numbers. I don't want to see all of them. As you can see, these correspond to 0 or 1. Now I can take the sum. So if I want the total number of passengers, this is how I'm gonna do it. Right? I'm gonna take the sum of all the true, because true counts as 1 and false counts as 0. So if I take the sum of all of these, I'm gonna get all the people who survived on the Titanic. That's 342 people. And I can also take the mean, because the number is to get the mean, we need to divide by the number of rows, right? Which is n row. Notice that I don't need to put this because the number of basically the number of rows in the column is the same as the number of rows in the whole thing. So I can just take the number of rows. I think if I actually do this, it's not gonna work because this is made to work with data frames, with like whole data sets that have more columns. So that this is not, this is gonna give me a null. So be careful when you do this. Don't write n row and then give it a column. If it's a column, because the column looks like this, right? As you can see, it's a column. It's not a data set. We need to get the length. So here I took the first 10 elements. If I get the length, of course it's gonna be 10, right? And here to get the length, it's gonna be 891, I think, right? So to get the mean, we can either do sum. We can sum all the people who survived and divide by the length. Or we can just take the mean, which is easier, right? I can just take mean. And it's going to give me the same number, which is useful. Oops. Okay, so sometimes you'll be asked for more than one thing to condition on. So for example, here, let's say that we have, if you remember this, I'm going to write it again. This is going to give me the joint probability. So let's say that there's a 9% chance that a person is both female and perished, right? I can do that manually. I can sum all the people whose sex is female and all the people that didn't survive, right? And I can divide by the number of rows, by the number of total people. If I do this, I should get the same number. And luckily, we get the same number. So basically, this is if this helps, if this gives you more intuition, this is what prop table does for you. So if you want to know if some person is female and they survived, then you just need to write this or use the prop table function. Now, for the conditional, now if you remember, we had the other prop table where we sum the columns. The 2 corresponds to the columns. So here when we sum, now we would say, okay, so given that the person is female, what is their chance of survival, right? What we can do here is we can actually take part of the data set out. So let's say that we just want to take the rows that correspond to female. So again, if I look at the data, this is how it looks like. And if I just want to take the rows where we have female, we can just do this. So this is going to give me all. So if you remember, here is where we select rows, and here's where we select columns. So let's say I want to take all the columns, so I'm not going to write any here. And for the rows, I'm going to say, just give me those rows where sex corresponds to female. And if I do this, this is going to print out the whole data set. As you can see, it can't print the whole data set because it's too big. There's like 800 rows. So you can see here, it always says female, which is what we wanted, right? Now I'm gonna save this data set. I'm gonna call it df.fem. So that's what I'm doing here. I'm just telling it, all right, that's how it's gonna be named. And now we can have a look at the data set. As you can see, it works. All the rows are just the ones that have female. Now this is one way to get the conditional probability that we mentioned before. So given that the person is female, what is their chance of survival? And that's exactly what we did before. We're going to sum all the rows where it says survived. But notice here that I'm summing only those rows where already I've chosen for them to be female. So I'm summing those females who survived, and then I'm dividing by all the women on the Titanic. So I should get the same number here. So let's look at prop table again. And we have the same number, as you can see. So given that the person is female, what is the probability of surviving? It's 0.74. And this is what we get with here as well. And again, we can get the mean if we want, which is the same, right? Because the mean is what? The sum divided by the number of observations. We can also use a different way to select. For example, here I can take the column. So I can take the column sex, but I can also only choose. I can, if I wish, I can choose only p class equal to 3. So for example, if I look at the data set, let's say that I want to choose only those rows that have 3 here. So the way we did this before is we're doing it like this, right? We're taking only the rows where p class is equal to 3, and then we're taking all the columns, right? So this is going to give me the whole. As you can see, I'm taking the whole data set only where the only rows that I'm taking are the ones that have 3 here. Now I can also take, let's say that I only want to look at the column that's corresponding to sex. So I can do it like this. And here I'm only taking the rows these are basically all the males and females that were, I think, in first class. I think that's what p class equal to 3 is. But there is another way to do that, which is here. I can first take the column and then choose which rows to take, which gives me the same thing basically. So these two things are equivalent. I can either take the whole data set and choose at the same time which rows to take, first class, and which columns to take, the sex, sorry, and then, or I can just take the column first and then choose which rows of the column to take. So both of these things are equal, as you can see. Now, why this is useful is, let's say I want to plot a table like this. Let's say I have this table. Here we have, as before, this is the one without the probabilities. Male, female, person survived, right? Now what I can do is, let's say that I'm only interested in this table, but not for the whole Titanic, but only for those people who are in first class. Well, the way I can do that is I can just say from this column, just give me those rows that correspond to first class, and again for the other one, I also have to specify that I want only the first class. So if I do that, I'm gonna take I'm getting a smaller number, right? Which is only those in first class. Now, as you can see, there's actually a difference here. So it's not, so a lot more people survived, I think, basically proportionally. Let's look at we can again look at the plot. Oh, doesn't seem to work. All right. Well, basically here we can ignore the I think we're ignoring here the sex, and we're just taking survived and P class, and we're taking both of these. We're basically looking at how does survival probability, how does survival vary according to class. So if you do this on your plot, I'm gonna remove the legend. Let's just remember that perished is the dark one, just against logical. I'm just gonna remove the whole thing, and this one you can write in your notes so that it puts the legend on the left side, so top left. But you don't need to write. You don't need to put that. So I'm just gonna remove the legend here. I'm gonna rerun the line again. Okay. Okay. So this gives me the unnormalized. Oh, actually, it was the other way around. My bad. So 3 is, I guess, the lower class because there's a lot of people that were going economy, and a fewer number of people that were first class. So you can see that the survival probability is very different. Here you can see that most of the people perished, but you can see that here actually a majority survived, which is how we can guess that. I guess that this was first class, because you don't have info on that. Now, as you see here, we have a much larger number. If we want to, we can normalize this so they have all of them have the same height. The height is useful here because it tells us there are more people in class 3 than class 1. But if you want to, we can normalize that. The way to do that is here you would put the whole thing in prop table. And if I do that, we'll get the, and don't forget to sum by columns, we'll get the normalized. So you can see this is how it will look like. See, the survival probability actually increases as you go from third class to first class. And that's mostly what you need to know for the homework. Thank you, everyone. We're just running out of battery.
Can you share that with us?
Sure.